Alright, so I'm doing similar polygons, meaning of similarity proofs, number 8. So, you are given a proof, and you have a drag and drop, so that makes it a little bit easier. But let's look at our picture. So, just looking at this, we see that we have two triangles, and we are given that BC is proportional to CD, and that AC is proportional to CE. Alright, and then we want to prove that triangle ACB is proportional to ECD. Now, whenever we are trying to prove that triangles are similar, we have a few different ways that we can prove them, and you've already seen at least two of these before. So we have side, angle, side, and then we have side, side. Looks more like a 5. Okay, let me get rid of that one. Okay, side, side, side. And then we have one that might be a little bit new, but it is angle, angle. Alright, so now, in side, angle, side, what that means is that you have two sides that are proportional, and then one angle that is congruent. So unlike whenever you're trying to prove that triangles are congruent, your sides all don't have to be equal, they just have to be proportional. Now in side, 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 you have three sides that are all proportional. And then in angle, angle, you have two angles that are equal. And if you think about it, if you have two angles that are equal, you're going to have a third angle. But we won't get into that. You just need two angles that are equal. Alright, so keep these in mind. These you're going to use in proofs to prove that triangles are similar. Okay, so let's look back at our problem and we'll see what we can come up with. Okay, so we were told that BC is proportional to CD, and that AC is proportional to CE. Alright, so we have two sides already that are proportional. So we know we can either use side, angle, side, or side, side, side. It just depends on what other information we have. So whenever you're going into your proof, what do we always put for our first statement? We always put the given. And then your last statement is always going to be what you're trying to prove. So in this case, bear with me. So in this case, we have that triangle ACB is similar to triangle ECD. Now we just need to know how we prove this, and we need to find what comes in the middle. So if we're thinking about how we can prove this, we either need angle that is congruent or another side. So looking at our picture, we see that they share a set of vertical angles. And we know that vertical angles are always equal. So angle BCA is equal to angle ECD. Alright, So now we have a side, an angle, and a side. And remember that when you're using side, angle, side, the angle that is congruent needs to be the angle in between the two sides. So let's see, this side and this side, the angle is in fact in between the two sides. Okay? So we can say that angle B C A is equal to angle E C D. Sorry, I kind of butchered that angle symbol. Let me see if I can make that better. Alright, that's a little better. Okay. Alright, and we know that because vertical angles are always equal. And so now we have three parts, and we can say that triangle ACB is similar to triangle ECD. Now I'm not going to fill out these two reasons. I'm going to let you figure out what to put in here and what to put in here. I hope this helps.